Hey, so today we're going to be talking about section 9.3, which is talking about rates of change and tangent lines. So first, if we're looking at the average rate of change for a function, and we're looking at an interval between a and b, then the average rate of change is going to be f of b minus f of a divided by b minus a. Another way of thinking of that is that's going to be the change in the y's divided by the change in the x's. That's going to give us the slope of the secant line, which is m. So here's what that would look like on a graph, is that you would have a point A, and then you'd have another point, let's say it's here, B, and then the y-coordinate would be f of A, and here the y-coordinate would be f of B. So the average rate of change would be the slope of the line that connects the 2 points. A line that connects 2 points on a graph like this is called the secant line. So this is the secant, and then the average rate of change is the slope of that line. So in this case, the slope of this line, so let's see, we would have 2 minus 0, which would be our y-coordinates, divided by 2 minus 0, which would be our x-coordinates. So we would have a slope of 1. All right, let's look at an example where instead of giving a function or graph, we're just given a table. So here, we want to find the average rate of change between 3 and 0. So that's going to be the x values. So what we need to do is we need to find the change in the x values, and those are going to be underneath the change in our y values. So if we take our y2 minus our y1 over x2 minus our x1, then that is going to be 15 minus 13 divided by 3 minus 0, which would give us an average rate of change of 2/3. Awesome. Now, what that leads us to, which is a much more important idea for the entire term, is going to be the instantaneous rate of change. Another word for this is going to be the derivative, and that is the slope of the tangent line. So here's the idea here, is that we have f prime of a, that's what we call the derivative, it's called the prime. So the derivative of a function f of x at some point a is going to be the limit as h approaches 0 of f of a plus h minus f of a all divided by h. That's going to give us the slope of the tangent line, which, remember, when you're drawing the equation for a line, is just called m. So when you think of the instantaneous rate of change, you can think of that as looking at a speedometer in a car and knowing how fast you're going in that exact moment. So here's what this looks like graphically. Is let's say that we pick a point A on our graph. And then we're going to pick a point A plus a little bit more, so plus h. Okay? So what we're going to be doing is that we are going to be finding the equation kind of a secant line. So the distance between these 2 points is h. Okay? Now notice that the limit is as h goes to 0, so we're getting these 2 points really, 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 really close to each other. And what happens when we get closer and closer and closer to this point is instead of having a secant line that goes through 2 points of our graph, we're going to end up having a tangent line. So a line that lays right on our graph that goes through this single point right here. So let's go ahead and look at finding the derivative. I'm using that definition. Don't worry, the definition can be kind of a pain in the butt, but what we're going to see is that it's not going to be too terribly bad once we get some quick tricks. So let's say that we want to find f prime of x. So what this means, if we look at the definition, is that instead of having an a here, which we have here and here, we're going to plug in an x. So that's going to be the limit as h approaches 0 of f of x plus h minus f of x all divided by h. So when we plug this in for x value, remember you're going to replace all the x's in your equation with that. So that's going to be 3 times x plus h squared minus 2 times x plus h minus, and now what we're going to do is that we are going to subtract just our original function, which would end up being this entire thing. So when we do that, we're going to be minusing 3x squared minus 2x, all divided by h. Now here's the thing, is if I just plug 0 in for h, I'm going to get 0 over 0, which we know we're going to have to do a little bit more work. So what I'm going to do now is I'm going to take this and I'm going to go ahead and expand it out. So if I expand this, I'm just going to go ahead and give myself a little bit more room. Well, if I expand this portion out, that would give me 3x squared plus 6xh plus 3h squared minus 2x minus 2h. Now remember, on the second part you have to distribute that negative, so it'll be minus 3x squared plus 2x all over h. Now I know that this looks really ugly, but don't worry, we're going to clean it up a little bit. First off, let's notice all of the goodies that cancel here. So positive 3x squared will cancel with that 3x squared. This 2x will cancel with this 2x. Great. So what I'm left with is these terms here. Now the cool thing is, notice that all of these terms have an h in common. So what I can do is that I can take that h and I can factor it out. So I get the limit as h approaches 0 would be h times 6x. So if I pull an h out of here, I'm left with a 6x. If I pull an h out of this piece, I'm going to be left with a plus 3h. And if I pull an h out of here, I'm just going to be left with a minus 2 divided by h. Now those h's cancel out. So what I'm left with is the limit as h approaches 0. Now, when h goes to 0, I can just plug that in. So if I plug that in, I'm going to be left with a 6x. This is going to become 0, because 3 times 0 is 0, minus 2, which gives me my derivative. Awesome. Now, the second part right here, f prime of 2, that says, hey, what happens if you plug 2 in for my derivative? So f prime of 2 would be if I plug 2 in for that x value, so that'd be 6 times 2 minus 2, which would give me 10. Now remember, this is going to be our m, our slope of our secant line. Or, I'm sorry, our tangent line. Alright, so the next thing we want to do is we want to find the equation of a tangent line to the point. So, what we need in order to find the equation of the tangent line is we need 3 things. We need to know what m is, we need to know what x is, and we need to know what y is. So let's go ahead and look up and see if we have some hints to this. So first, notice that at the very beginning of the problem, they gave us that we're looking at the point 2, 8. So what that tells me is that my x value is going to be 2 and my y value is 8. Now my m value, well, I just found that in the last problem, that's going to be 10. So the equation for the tangent line is going to be a straight line. So our graph is going to be an upwards facing parabola. It's going to look something like this. Or no, it'll actually be at the origin, but whatever. So our tangent line is going to be a straight line. which means the equation for the tangent line is going to be y equals mx plus b. So if we take this information and we plug it in, what that's going to give us is 8 equals 10 times 2 plus b, which means we can solve for that y-intercept. So we're going to have 8 equals 20 plus b, which means b will have to equal negative. So let's see, if I take 20 away from 8, that's going to give me negative 12. So the equation for my tangent line would be y equals 10x minus 12. Perfect. Great. So if you need a little bit more practice on any of these or have any questions, shoot me an email. I'm also going to be posting a second video with some more examples.